Alright, this is a short video on kind of a really simple but important point. What does it mean to have zero? What does it mean when you say a vector A is equal to 0? Alright, well, a vector is 0 if, and only if, its magnitude, that is its length, is 0. That's the easiest way to think about it in polar form, so it basically is just that. And since it has no length, it really doesn't matter which way you say it points because it's not going to actually leave that spot. So if you go 0 miles, it really doesn't matter if you're facing east, west, north, or south. Another way, equivalently, in terms of our Cartesian representation or other representations, spherical, cylindrical, is to say all of its components are 0. Now, this has some impact on you when you start dealing with vector math later in the course and elsewhere. So let me show you an example. Let's say that a vector, we were told, was given by this equation. And we're told that A is 0. And you see this equation. A is 0. Now normally when you see A is 0, people want to say, well, how many things can you solve if you have this one equation? And they'd say, well, you solve one. Well, that's a scalar equation. In vector land, when you have this equation, you know that each of its components, which are scalars, are 0. So if you have a three-dimensional problem like this, you in fact have 3 equations, not one. One vector equation leads in this case to 3 scalar equations. For instance, it says 3x plus z has to equal 0 because this component must be 0. It says that y minus 2z is 0 because this component must be 0. And it says 4z is 0 because this component must be 0. So you can solve more than one thing. You can solve, in fact, for 3 things. And in this case, I have 3 unknowns, x, y, and z. So if I'm trying to solve this problem, I know z is 0 because I can divide both this side and that side by 4. And this produces 1 times z. And 1 times anything is just itself. That's really what you do when you so-called cancel. You create crazy ones. And when you look up here, you can now take this 0 and put it in here, and you get y minus 2 times 0 is 0. So that means y is 0. So I now know that fact. And on this, I have 3x plus 0 is 0. Which tells me x is 0. So in fact, I know x is 0, I know y is 0, and I know z is 0. In fact, the only place where this vector would be 0 is at the origin. That's what I get out of this equation. We'll be doing things like this later in the course when we sum up forces and the forces equal 0. Not only the x component of the force would be 0, but the y component of the force is 0, and if it's three-dimensional, the z component. So there are a little bit of fine differences between vector math equals 0 and scalar math equals 0 that we'll have to deal with. So make sure you know what this definition says. A 0 vector is a vector whose length is 0, or more useful a lot of times is to note that each component must be 0, and each component can give you an equation that you might be able to solve something with. One last thing, you might think that this is true, and it does make sense. We never talked about subtraction. So what does this mean? A minus A. Well, this is A plus minus 1 times A. And that we have talked about. That's multiplication of a vector by a scalar. So if this vector was like this, and that's A, then we know that minus A turns it around in the opposite direction and makes it the same length. So when you add them, you go up here, then the minus, because of the scalar, turns you around, and then you add from the tail to the tip, going the other way, and you end up right back where you started, which tells you that it's equal to 0. Notice that 0 is the only time I don't have to put an arrow over, because it doesn't matter which way you rotate, you're still at the same starting point. I also don't really have to worry about units, although I would usually put those there. So we have talked about subtraction. Subtraction is addition when the second one is multiplied by a -1, which is multiplication of a vector by a scalar. So it's a special case of what we've already talked about. Alright, this covers this part of the material. The next thing is to start talking about the fact that there are two totally different ways that can occur when you multiply a vector by another vector.